Okay, first let's talk about energy conversions, energy stores and systems. So a system essentially is an object or a group of objects, things like a kettle filled with water. That's a system. So an energy is stored in these set systems. So they can do different forms like kinetic, thermal, electric. You need to know these types of electric stores, like what kind of things they are. So kinetic will be just like things like a car running, thermal, temperature, and all of that. You need to know what all of these are. I'm not going to explain them one by one. The understanding of energy, and you need to know this clearly, is that the conservation and dissipation of energy, and the principle of this is that energy is never created or destroyed. You never say it's created or destroyed. That's a very big mistake. Energy, however, can be transferred. So if we look at the explanation down here in the car diagram, we see that there is initial just chemical energy. The total is 4 bars. After maybe driving it for a while, some of it's going to turn to kinetic and some of it's going to become thermal. The total energy is still going to be 4 bars, but it's going to be transferred to different stores. Some of it's useful, some of it might be wasted. So in this case, thermal is probably going to be wasted energy because the thermal was probably from like the engine or the friction from driving the car. Some of it may just be wasted energy, but at the end of the day, all of it's just transferred, never created or destroyed. That's something important to note. These questions, all of this was math. So if you want to have a go at those, please do have a go after the session, but this is all math. Okay. With specific heat capacity, there are a few things you need to talk about with this. You have the diagram on the right, and it's showing you there is a change from like solid to liquid to gas. You can see that over time, and the temperature, when it's going just solid, all the way from the beginning from solid to liquid, there's a point where it just levels off. Time goes by, and internal energy is changing, but temperature is not. So you can see that when the place it is leveling off, that is the melting point or boiling point of change in state. So if something goes from solid to liquid, and you can see that there is a point of leveling off, that is the melting point. However, this is not to be confused with the internal energy. Temperature may not be changing, but the internal energy is still increasing. So this is something to remember. You have the specific heat capacity equation. Sometimes they will ask you to do math on this, which is energy equals mass times specific heat capacity times temperature change. You will be given this in the summary sheet, I believe. And that is just the specific heat capacity is just the change in thermal energy associated with the temperature change in a system. Latent heat of evaporation is just the energy required to change the state of 1 kilogram of substance without changing its temperature. So you can see in the area where it is the melting point or the boiling point, I told you internal energy is increasing, but temperature isn't. So that area is essentially the latent heat of either fusion or vaporization, depending on which one we're talking about. This is also given in an equation, E equals ml. I'm not going to explain those equations any further than that. Right. So let me just say this a bit more detail. Specific latent heat are there's 2 different types: latent heat of fusion, latent heat of vaporization. Latent heat of fusion is the one melting point, and then latent heat of vaporization is the boiling point one. So those are the 2 ones, but they're all essentially just the energy required to change from solid to liquid. That's the understanding of specific latent heat, specific latent heat.